Hey, we are way too loud. Okay, in your notebooks. All right, so we'll be getting started here shortly. Please come into your notebooks and let's update, because we're going to be starting a new investigation. So now you are going to skip, and we're going to start investigation 4. Okay? And this investigation is called Electromagnets. Our first part is building an electromagnet. For me, that's page 14. For you, it might be a different page. So go ahead and get your notebooks up to date. And we'll continue in just a minute. Alright, so we're going to come back in about 30 seconds, so please get us caught up. All right, please make sure that you add this into your notebook on the next. Here's the important thing. Do not add it to the next blank page because you still have to do analysis and conclusions for this morning's investigation. So leave one page for analysis and conclusion, and then write your building an electromagnet. 1, 2, 3, 4. How many is this?
Yeah. We just need to, right? Oh, it's not starting.
Here. Focus here. This is the sixth one?
Yes, so just one more.
So take these back. Just take them back for now. Do this with them. Just take them and just wrap them over here.
Oh, these are really bendy.
Quickly, wrap it quickly and set them there because we need to get started. Let's see, here's one. All right, so I'm going to start off by just kind of telling you a little story about what we're going to look at. We know that we have temporary magnets, and we know that we have permanent magnets. Now, the temporary magnet, I can turn it on, or I can make it a magnet by doing what to it? By rubbing it with another magnet. So I can take a piece of iron, rub a magnet against it, and it becomes a magnet. Now, how do I take the magnetism away from that iron object?
Bang it or...
Bang it on something and the magnetism goes away. Now, do you think that there is a way that I could make a magnet that I could just turn on and off?
Yeah.
Like a permanent magnet? Like one of those, like one of these really strong magnets that I have, known as a rare earth magnet. Okay, can I make a magnet that's as strong as this and be able to turn it on and off? Okay, where it's going to pick up heavy objects and be able to turn off whenever I want it to turn off. Jackson.
I know the answer is yes, because in an MRI machine that has magnets, the MRI machine isn't always on. They have to turn it on before you go in.
Well, the MRI machine is not always on. Now, we don't know if the magnetism is always there. We know that the picture part that takes pictures, they turn that on. But the question is, does an MRI machine always have that magnetism around it? Or can they turn the magnetism off? Okay, for example, in a magnet like this, can I turn this magnet off? No, it's always going to be on. So can I take a magnet and turn off its magnetism? I guess that's the question we're asking. Can I turn off a magnet's magnetism without having to bang it on something?
Yes.
Okay? So that's what we're going to look at today. We're going to spend some time investigating that idea. Okay? Now, hopefully we've been able to pull out a lot of our science materials. Okay? Now, the reason I thought about this was because I remember when I was a little kid, one of the things that I loved to do, for some reason, I don't know, I really got into recycling when I was a kid. I thought it was the coolest thing. And so we learned in school about energy and conservation and saving the environment. And one of the things they told us was that the amount of energy you save by recycling an aluminum can versus them having to make it brand new was a lot. And I said, well, what does that mean? Well, basically what that meant was if they have to mine the material out of the earth, turn it into aluminum, then take that aluminum and make a metal can out of it, and you take a look at all the energy it took to make that can, and you compare that to a can that's already made, and you melt it and make a new can out of it, the amount of energy you save is ridiculous. And so recycling is a big deal. And so as a kid, I really got caught up in that. And so every time we had sodas, I always saved the cans. I always saved the cans. I'd tell my family, don't throw them out. Don't throw them out. Got to save them. And after I had a whole bunch, I would take them to the recycling place, and they'd recycle them. And then to make matters even better, they'd pay me for giving them to them, which was even awesome. Because I was doing something that I thought was helping the planet, but at the same time, they'd pay me for it. I was like, oh, you got to be kidding me. But the thing that absolutely fascinated me was that at these yards, these recycling plants, they also recycled steel. And they had huge chunks of steel at these places. And they would take all this steel and they would load it up onto trucks. And these trucks would take it to these plants where they would melt it and make new stuff. But what absolutely fascinated me was these magnets that they would use. They would have these cranes that would come, and they would drop this thing into these big containers of steel, and they would lift up tons of material, these huge metal bars. They would pull them out, and then it would swing over to the back of this truck, and it would swing over and it would hover above, and then all of a sudden, the stuff would just fall off of it. And I was sitting there going, what in the, that is like crazy, because I knew it was a magnet. It's got to be a magnet for the stuff to be stuck to it. What I couldn't understand was, how in the world does the stuff just fall off? That's like turning off the magnet. And I'm like, how can you turn off the magnet? And so that was something that was extremely fascinating for me. And so the question was, can we make something that we can turn on and off? Okay. Well, you know that you've used magnets in the past. You've used those tiny little magnets, these little donut-shaped magnets.
Yeah.
That we've seen. Okay. So let me kind of show you the magnets. Okay. So we've been able to look at these magnets. And so I know that this magnet will pick stuff up. And so if I have rivets, if I have little tiny washers like these, okay, I know that I can pick them up really quickly with this magnet. The problem is, I can't get them off. What's the only way to get them off?
Bang it.
So take them off, but
Yeah.
Can I bang the magnet against stuff to turn them off?
No.
No, the magnet's not going to, this is a permanent magnet. There's nothing I can do to turn off this magnet. So the only way to do that is to actually what?
Take them off yourself.
To actually just kind of pull them off. And so I have to use force to break the magnetism and get them off. Now the problem is, if I have a very, 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 very powerful magnet, like this one, and I come down here and do this, okay, they stick pretty hard to this. And so to break this force, it's a little harder. Now imagine a huge magnet that picks up something that weighs several thousand pounds. Imagine how much force is between that magnet and that piece of iron. Would you like to be the person that has to climb up to the crane and tries to pull that off?
No.
Yeah, not really. Okay? And so the idea then is that we need to figure out a way to turn a magnet on and off. Now, what are some things that we could use? When you think of on and off, what do you think of? You think of a circuit. You think of a circuit with electricity. Okay? So what I'm going to do is I'm going to give you materials to build a circuit. I'm going to give you a cell holder. I'm going to give you a wire. And I'm going to give you a cell. Okay? Now, so here's your materials. If you want to add a switch to it, in fact, I would say, yeah, go ahead and add a switch to it so that you can turn it on and off. But I want you to build a circuit that doesn't necessarily have anything. It's just a circuit. And you're going to plug it in, and you're going to turn it on, and it's not going to do anything. But would electricity be going through the wire if I plugged it in correctly? So electricity should be going through the wire, even though there's no light bulb, no motor for me to see it. But I know, because I've been doing science, that electricity is definitely going through that circuit. Now, once you have that circuit built, okay, what I'm going to have you do is I'm going to start looking for magnetic fields. Now, there's something that I discovered. There's a tool that I can use to search for magnetic fields. What tool?
The compass.
The compass. How does a compass help me find a magnetic field?
Does it have like a magnet in it?
A compass does not have a magnet in it. Leah?
The needles, they move wherever a magnet is, so it'll just spin and spin.
Okay. So, the little needle that's in there, okay, we wouldn't necessarily call it a magnet. It's a piece of metal that has a slight induced charge, right? So we could technically call it a magnet, but it's not really a magnet. I can't pick it up and start picking stuff up with it. Okay? It's got a little bit of induced magnetism in it, and the reason it has that is because it's going to point in a certain direction. Now, what would happen to this compass if it comes in contact with a magnetic field? What will happen to that compass when it comes close to a magnetic field?
It'll start spinning.
It'll start to move. It'll start to act weird. So if I bring a magnet close to it, you'll start to notice that this compass starts to act kind of odd. It starts to move around. Now, if I see a compass doing this, what do I know is happening?
There's a magnetic field.
I know there's a magnetic field somewhere. Okay? So, in fact, I could say this is a compass that gives me the directions, but this is also a...
Compass that gives me directions into a magnetic.
I could also call it a what detector?
Magnetic field.
A magnetic field detector. So I could walk around my house if you have a compass and start going, let's see if anything here has a magnetic field. And so you could just kind of start going, let's see, the remote doesn't. The iPad, If I put it next to the iPad, it kind of moves around a little bit, which means this iPad must have a magnetic field in there somewhere. So I said maybe inside there's magnets inside of the iPad. I don't know. Okay? But what I'm going to have you do is I'm going to have you create a circuit, build a circuit with these materials, a circuit that's working, and then I'm going to have you take your compass and start to investigate and see, I wonder if there's a magnetic field in a circuit. Okay? So let's go through that first. All right? So, getter ones, I want you to go up there, get a cell holder, a cell, a wire, a switch, and a compass. Take those materials back to your table so that you can start to investigate whether a circuit has a magnetic field. Okay, we're going to spend 5 minutes doing this. This should not take us that long to do. So grab your materials and we're going to spend 5 minutes searching for magnetic fields in a circuit. Okay, you're probably going to need 2 wires if you're going to use a switch, only 1 if you don't use a switch. Okay? Alright, here we go. 5 minutes to look for a magnetic field. Anyone need? Did any group not get a cell holder? Some groups might be out. Or did you get enough?
We had one after.
Okay, build a circuit quickly. You've got about a minute to build a circuit.
Did he go to a different school? What's it called? Electromagnet.
He'll do it when he wants.
Did you guys find anything? Yeah? Okay. 10 seconds.
So apparently all
Can I borrow yours? Alright, time is up. So let's kind of take a look at what you built and what you did. Okay, what you should have done is when you build a circuit, you would have built a circuit that looks something similar to this. So what I have is I have a circuit that has electricity that will travel through it when my switch is on. But when the switch is off, there is no electricity traveling through the circuit. Now, in order to test whether there's a magnetic field here at all, or if there's anything, would be to take this compass, and let's say I'm going to put it right here. So I'm going to put it close to, and I'm going to zoom in a little bit so I can see the compass needle there a little bit better. Now, so right now the circuit is off. And I notice that the needle is pointing in, let's see, let me turn it. So we'd see that there that it's pointing in the north direction. Now, if there's a magnetic field, what should happen when I turn this on? The needle should move. The needle would only move if it detects a magnetic field. So let's plug this in and see what happens. Okay. All right, so we get here. Okay, so here I'm not seeing a whole lot. Now the only thing that I could possibly see here that might be a problem is that when I came to this group, your circuit was on. You never turned it off, which means you may have drained your battery. Okay, so please make sure that your circuits aren't on. Okay, you only turn it on to test it. If you leave it on, then basically you're going to completely drain your battery. Okay, so this battery might be dead because it was on when I borrowed it. So let me borrow another team's. Is there another team that has a circuit? Can I borrow yours, McKenna? You guys are the closest, so let me just take this here. Okay, so let's try another one here. Okay, so hopefully, you guys didn't have yours on, did you?
when you were talking.
Oh, while I was talking, you turned it off. All right, well, we'll see. So there's my compass pointing north. Let's turn it on and see if we notice any difference at all. Okay, so here's my wire. Okay, when I turn on the circuit, let me back this up a little bit. Okay, watch, I'm going to turn off the circuit. The needle goes back to that position. I turn it back on. Okay, if I turn on the circuit, let's see. Do I have any movement with the needle when I turn it on and off? Okay, so when I turn my circuit on and off, I do have some movement of the compass needle. What does that tell me?
There's magnetic field.
It tells me there's a magnetic field there. Okay, now, where is the magnetic field? Where is it happening?
You don't know.
What's that?
I don't know. Switch.
In the switch?
The wire. The cell. The wire connected to the electricity.
It's in the electricity?
Yeah.
Well, I wouldn't say it's in the electricity. Where is the electricity?
Inside the wire.
Electricity's in the wire, so the magnetic field must be where?
The wire.
In the wire. So, what I want you to do right now, okay, we're going to come back to our notebook. And here's your focus question. How can you turn a steel rivet into a magnet that turns on and off? How can you turn a steel rivet into a magnet that turns on and off? That is the focus of this investigation. So let's think about this for a second. So if I have discovered that there is an electric field in a wire, what does that mean? Now, is there an electric field in every wire?
No.
Only when what?
It has electricity.
Only when there's electricity going through it. So a regular wire does not have a magnetic field unless there's what?
Electricity.
Unless there's electricity going through it. So the question is, if I know that this has a magnetic field, how can I use this to create a magnet that I can turn on and off? Think about what I learned about magnetic fields in the last investigation. How can I turn something into a magnet that's not a magnet? Is the steel rivet a magnet? No, not unless I do what, Celeste? Hold on, not yet. How do I turn a steel rivet into a magnet? I have to do what?
Rub it against the magnet?
Rub it against the magnet? Well, if rubbing it against the magnet is not what gives it its magnetic, turns it into a magnetic. Okay, what is it that makes an object become magnetic?
Induce.
I have to induce magnetism in the rivet. How do I do that? How do I induce magnetism in the rivet? Celeste?
You rub the magnet on it so the atoms go.
Do I have to rub the magnet on it?
You just have to put it in
No,
the magnet.
you can just touch
I have just put it in the magnetic field of the magnet. Okay, so it could touch it or it doesn't have to. Now, what did we learn? Where is the magnetic field the strongest? Close to the magnet or far from the magnet? You learned that this morning.
Close.
Where is the field the strongest?
Close.
Very close. So in other words, this wire that I have in front of me is going to have a magnetic field
It is?
if I run electricity through it.
Oh, yeah.
So how could I make that magnetic field get past to the rivet? Okay, and you'd say, well, I don't know what a rivet is, Mr. Perla. Isn't that an onomatopoeia? No, that's rivet. This is a rivet. How can I pass the magnetic field from this wire with electricity to the rivet? Okay, that's your next part of the investigation. Okay, you're going to take this really long wire. You're going to take your circuit base, you're going to take your cells, you're going to take all your materials to make a circuit. And you're going to add a rivet and this really long wire. And the idea is to build a circuit that's going to allow the electricity to go through this yellow wire, but somehow I need to get that electricity to transfer its electromagnetism or magnetism into the rivet. And that would do what to the rivet?
Turn it into a magnet.
It would turn it into a magnet. Now, what would happen if I turned off the circuit?
It would turn it into a rivet.
Would the magnetism go away in the rivet?
No. No. It would stay there for a short time.
It might stay there for a short time, but for the most part, it would turn off, right? Okay, so that's the idea. Can you do that? It is 3:25. We're going to give you about 5 to 10 minutes to experiment with that. See what you can come up with, because we're not going to tell you how to do it. Okay, so you're going to build a circuit, and then you're going to test it. How are you going to test it? Well, you're going to take some of these little washers, and after you've built your circuit, if it is a magnet, what's it going to do? You're going to be able to pick up some washers. If you can pick up some washers, then you've created a magnet. If you can't pick up washers, then you don't have a magnet. Make sense?
Yep.
Okay, all right, grab your materials and get started. You've got 10 minutes.
Analysis and conclusions. What are you supposed to do for that?
You need to talk about what you did and answer the question that was there.
Oh, what happened to the Okay, guys, I got it. Oh, wait.
I think this will work better.
Check under the other side.
Up there.
Yellow, white, like the blade I'm not. Got it. Almost.
Where's the ribbon?
We need that. Let's start from the green. Put it like this. I feel it. But we need this one. And it's a longer wires. Here, guys. Where are the washers? We don't need the washers. Give us at the end. Well, we're done. Yeah.
Oh, I do. Let me come around.
The washers. Here, put them on. Put them on.
Sophia, where are the wires?
No, you untake it. What have I done? What have I done? Right there.
Are they still here?
Do you have another copy of that?
Of what?
What he's doing?
Oh, yeah, I have to print it. I
Oh,
have
no,
them
don't
on.
worry about that.
I have
Just
them
at
on
some
my.
point, that would be cool to have.
Yeah. It's actually been highly successful.
That's the same thing I did with my kids when they were growing up.
You know, I did it with the I did it with the first grader when I student taught. That's when I came up with this, and I had a first grader. That was her attempt at taking control. I could
Ask Mr. Perla.
It was. You need to find it. Okay. So that was really amazing. And so when you did that, it's amazing because sometimes you get and it's quite it's something you're trying to know, but it means it's her. What she had said was, say this again between now and I should not be allowed to.
They were put away.
That was, and I was like, oh, I never would have thought of that.
So you created that one? Where did you find it?
I found the idea somewhere, but I tweaked it and then I added the whole plan to the very end. And it was amazing because she did really, really well. For like a morning, and then it was like, here's a way to close that.
Oh, no.
And I thought, look. So long. I didn't know what it was. I just followed through. And of course, when I really figured it out, she was like looking at me and I know I can't go down this part.
Figured out what a steel gun is.
And so sure enough, I think the other end.
Sounds good.
Maybe we should just go to Mr. Perla and tell him he just
She's still got it down.
because the inside is inside.
Oh my gosh, it's devastating. From February to the end of the year, no more. And prior to that, it was once a week, twice a week, 3 times a week, depending on what her mood was.
Made its impact.
Oh, absolutely. But again, the Valentine's party apparently was the most meaningful thing to her, and I never would have thought of it.
Now we can wrap it.
Yeah, it's wild. When you give them that chance, you might be shocked. Here, let me cut.
Okay, guys.
4 minutes.
You don't know yet? Come on.
It's not working.
He has no idea.
No, he's gonna get them. He's gonna get them. Maybe you're just putting the south side. South side.
Can't have any electricity.
North side to the north side.
Now, what if I do this? Do I have electricity on this one?
What do you want me to do about it?
Why not? going to go through that wire. It's like part of the circuit. Why do you think this wire is so long? Now, when you put the magnet next to the compass, does it move a lot? When you plug in the circuit, does it move a lot or a little? When you put the compass next to the circuit, did it move a lot or just a little? Why do you think it moved a little?
There wasn't any.
Are the ends of your yellow wires cut already?
Yes. I'm gonna wear this. I'm ready, guys. Want to take pictures?
Chop, chop, fresh.
Wait, this is oh my god. It actually works?
Did you figure out how to make it work?
Yeah.
And your missing items?
It's like and I don't feel like
It's not right. Don't turn the radio on. Unless you're testing it. Unless you're testing it, it shouldn't be on.
But not the box?
It's on right.
Oh, yeah.
Unless you're testing something, it shouldn't be on. I know there's a magnetic field. I don't need to test that anymore. No one's done that. Now the key is how do I get that magnetic field onto the radio?
Want me to pass them out for you? I know how to. Do you want me to pass them out?
Not yet. What's wrong?
Found a way to test it.
To test what?
To test the orbit magnet. I believe my lock was made of iron. We tried to connect it, and it actually worked.
Okay, I'm going to come around and give each team a few washers so you can test. Okay. Make sure your circuit's not on unless you're testing it. Is there any electricity going through that wire? This wire? Is there electricity going through?
It's not.
Not yet. What do you mean? Is there any electricity going through that wire right now? Why not? Because a circuit always has to go back to... Right now I have... there's no... It's not getting back to the start.
2 years. Yeah, sure you did.
So this end needs to be here. Did I give you some washers?
Wait, did you say God?
In about 6 years, you guys can
Look at this.
All right, time's up. Hands on your heads. 5, 4, 3, 2, and 1. All right, so I'm going to give you some hints. I'm going to give you some hints, which means your hands are now off the science materials. When I bring a magnet close to a compass, I want you to notice how much it moves. Okay, when I bring this magnet close to the compass, does it move a lot?
Teachers, students, please pardon this interruption. We have a few reminders. Today is the first meeting of the golf.
Okay, it moves a lot.
Happening
Why?
after school, we're asking those students to meet.
Why does it move so much?
Chess club is meeting in the media
Because of the magnetic field. What happens if I put this even stronger magnet? Does it move even more?
Is meeting in the science lab upstairs in the back corner.
Why does it move more?
Also, pennies for pasta update. Pasta for penny.
Magnetic field is
We're
stronger.
still counting, but Miss Nickersher's
Now,
class is in the lead.
when I
with
ran the
over
wire
$78 collected.
over it,
Nice job,
did it
Miss
move a
Nickersher.
lot or a little?
And currently in last
A
place
little.
is Mrs. Galindo's.
Why did it
program.
move so little?
So we've got some work to do to get caught up. 7th graders, so please.
Because the magnetic field in the wire is very small.
Pennies for pasta, and
So,
we'll continue
since
to
the
collect and
magnetic
update
field
the
is
totals
small,
in the morning announcements.
the only way that I can get enough magnetic field around the rivet might be to do what?
To increase the energy from the battery to
Increase the energy from the battery? Or, why do you think this wire is so long?
To wrap it around a bunch more.
Okay, maybe to wrap it around the rivet. So I can get a lot of magnetic field from the entire wire around the rivet. Now, please keep in mind that you will not ever have a circuit if you take your rivet and do this and wrap it around and then plug the other end of your wire and then you're touching things. Okay? In order to have a circuit, the wires all have to go back to where? They all have to go back to the cell. If they don't go back to the cell, then you don't have a circuit. So if I have this wire here like this, but this end of the wire isn't plugged into my circuit, I don't have a circuit. There is no electricity traveling through this. Make sure that when you build your circuit, you have a path that goes from the cell all the way through the yellow wire back to the cell. Once you have that, then you can try using that wire on the rivet to see what you get. Okay, so until you do that, it doesn't make any sense for you to test because there's no electricity going through that wire. Okay, now, today you got to experiment a little bit. Here would be my suggestion if you're going to attempt to do this. In order for you to have enough wire here to be able to plug this in, I would take maybe this much wire that's left over and start wrapping it here. Okay? That way, as I wrap, however you're going to do this, if this is what you're planning on doing, okay, I'm not saying this is what you're going to do, but if this is your plan, in order to be able to build this for a circuit, I need to have wire on both sides, don't I? Okay, so now if I do this, I have two ends. You'll see I have two ends here. And these two ends can be attached to my circuit. Make sense? And if I attach these two ends to my circuit, is there electricity going through the wire? Yes. And it's going through the wire and it's next to the rivet, and we could attempt to see if there is a magnetic field. Okay, so tomorrow we're going to continue to work on this. So tomorrow morning when you come in, make sure that you grab your science materials, head back to your table, and start to think about what new ideas you might attempt. Okay? In the meantime, listen up very carefully. In order to make sure that your cells are not dying, circuits should always be open. I'm going to ask you to have one person in your group in charge of making sure that circuits are always open unless we're actually about to test. Okay? The second thing, this yellow wire, how do I want you to get rid of it? Or how do I want you to put it away? Here's how you're going to do it. You're going to take this yellow wire. Okay? You're not going to start until you've seen me do it, Jason. Okay? Take this yellow wire, gently wrap it around your hands like this. Not tight, because then you're not going to be able to get your fingers out. So gently wrap it around your fingers, slide it out like this. Then what you're going to do is you're going to take your fingers and just kind of hold it on the end and just twist it. Twist it so that it looks like a number 8. Okay? Once you do this, you can then put this wire back into your science materials and you're not going to run the risk of getting it all tangled up with everything else. Okay? So we're going to stop here. We're going to come back and we're going to continue from here tomorrow. And we're going to continue to build our electromagnets tomorrow. So, Ms. Taylor's class, Ms. Richard's class, thanks for joining us. But we'll start off from here tomorrow. All right? Thank you very much. See you tomorrow.